Okay, so last part remains for problem 8. So let's go for part 4. Alright, so phi of 0, plugging in 0 gives us C1. So we'll keep that around, and let's plug in pi, but this time we have to keep the negative in front of it. So that's going to give us negative C1 cosine of pi k. Now I write this because our answer is going to vary again. So in this case, if k is odd, then we're going to have C1. If k is odd. And we're going to have negative C1 if k is even. So very similar to our previous part. It's just that because of the sign change, the negative is applied. Our case is flipped. Okay. So let's keep this and go to our next part. So phi differentiated once equals of 0. That's going to give us C1 again. Sorry, I'm looking at a different one. So we have to look at the second equation we have. So that's going to give us KC2. Okay. Alright, and use the same equation, but now plug in pi. So this is going to give us C positive K, C2 cosine of pi k. And again, we're going to have two cases where it's going to get C, K, C2 if k is odd, and negative K, C2 if k is even. Alright. Again, we're looking for non-trivial solutions, so if our k is even, for both of our cases, well, let's look at the first case. If k is even, then we have C1 equals to negative C1. This only gets us to one answer, one possible answer. C1 has to be 0. This might be okay if our C2 holds a different value, so let's check. Alright, so if k is even, then we have k c squared, c2 equals to negative k c2. Again, we can divide out k both sides. Okay, assuming that k is not 0 at the moment, then we have c2 equals to negative c2. And this gets us to c2 equals to 0. So when we have phi of x equals to 0 itself, then that's a trivial solution. So for both of our cases, we have confirmed that k cannot be even. Alright, let's just check what happens if k is odd. If k is odd, we have c1 equals to c1, which means that c1 can be any value. Likewise, here's kc2 equals to kc2. Again, c2 can be any values for us. So, therefore, we conclude that k is odd. I think in our book it writes in a form that k is 2n minus 1, where n is 1, 2, 3, 4, 5, 6. But if you just write k as k, the value of k has to be odd, that's fine.